So today we're going to be looking at identifying a pattern. Now, one of the things in these introductory sets is terminology is an important thing. So with identifying a factor, we want to know what do we call a quantity that does not change, a known value. Well, what we call a known value is going to be a constant. Actually, let's do this in green, because why not? This is a starting thing. So something that we know is constant. If I know the value for 7, 7 does not change value. 7 is 7 today, 7 is 7 tomorrow, 7 is 7 next week. It's 7 at the top of a mountain, at the bottom of a valley, in a boat in the ocean. It doesn't change because we know the value of it. Conversely, a quantity that changes depending on the situation, or mostly what we refer to as an unknown value, is going to be a variable. These are values that, depending on the situation, might be something else. Now, it's not that it changes. Depending on the scenario, we don't know what the value is. How many calories does it take to survive? Well, maybe on a slow day where you're just sitting around reading books, it doesn't take a whole lot, versus if you're running a marathon. So it changes depending on the situation because we don't know the situation of which we're not required to plug that in. We have two other things that we're going to look at. A numerical expression is a mathematical statement. Using only constants. So in this expression, we're stating that some mechanism, some behavior is occurring, but we're only referring to constants, things that are known. Conversely, with this one, the algebraic expression is a mathematical statement that uses both constants and variables. Perfect. So this one, we're stating that something is occurring. We're not sure as to the process, but it's using both things that we know and possibly things that we don't know. So without further ado, let's go ahead and jump into a few of these examples. Okay. So most of this is just vocabulary based, so we can knock these out fairly quickly. One is going to be a variable because we're not sure what the value of n is. N can be the number of pizzas you can eat. N can be the number of bicycles you own. We're not really sure what the value for n is. So we're going to go ahead and just state that n is a variable. Same thing. Number 3, x is also a variable. And it's the most famous variable because it changes depending on the situation. Which equation you're solving is going to dictate a different value for x. Unlike these, which could be very much different things, 45 is always 45. It doesn't change no matter who writes it down, no matter when you read it, where you read it. So it is a constant. Same with 16. 16 is the same today, tomorrow, and the next day. Perfect. And now the next few, you might be tempted to look at number 9 and say, okay, 21 minus 14. Well, that answer is 7. But again, we're not concerned with what the answer is. We're concerned with the actual statement. I'm taking 21 minus 14. So something's occurring where I had 21 and I'm taking away 14 of something else. I'm not sure as to what the scenario is representing. So therefore, a statement is being made because I have an object, or not an object, an operator here. Because I have this minus sign, it becomes a numerical expression. Actually, that minus sign becomes an expression. And then I would go through and identify I am using only constants, 21 and 14. Therefore, this is a numerical expression. Okay. We're not concerned with the answer. We're only concerned with what is being said. Same thing right here. Because I have an operator going on, I have a minus, I have a plus, and I have implied multiplication going on. I have a lot being said. But if I go back and I look at each one of these are all constants. So because I have an operator, I know it's an expression. It's using only constant vocabulary, so therefore it is a numerical expression. Awesome. And then lastly, what I've got going on right here, I see operators again. I notice that, okay, statements are being said, so let's make it an expression. But I do have this variable that's going on, my x. So because there's an x somewhere in this expression, I know that this isn't a numerical expression, this is an algebraic. Perfect. So that being said, let's go a little bit deeper into this, and we've got some questions that you might want to consider. Can we have a numerical expression within an algebraic expression? What is a quantity? What makes it more than just a value? And can you think of a quantity that has no value? So let's take a look at the first two. So can you have a numerical expression within an algebraic expression? So let's go ahead and start out with a numerical expression. What would a numerical expression be? Well, we had one earlier with the 21 minus 14. So let's write down that 21 minus 14 and see what we can do. So as of right now, we have our numerical expression. Check that off. I want to turn this into an algebraic expression or add an algebraic expression to the outer portion of this. So why don't I just go ahead and say, let's make that my numerical expression, and I can make something as simple as, let's add an x. So therefore I have my numerical expression. Now the overall expression is algebraic simply because I added that in. So algebraic, check. So yes, we can have a numerical expression within an algebraic expression. Yes. The second is, what is a quantity? What makes it more than just a value? So let's take a look at these terms. Let's look at a value. So values are something like, let's say 17, 18, 21, negative 105. These are all values. However, a quantity, we have to give it some sort of perspective. So we've got values right here. What makes it a quantity? Well, how about we make this 17 school buses. That turns that value into a quantity. You gave it some sort of perspective, some sort of reference point. It's not just 17 in the number. I'm now manipulating school buses. So if I get an answer that says your answer is a value of 17.5, I know that doesn't necessarily represent a full quantity. It might represent 18 or 17, or I might be able to use 17.5, depending on the situation. So another quantity would be, let's say, 18 children. This is something where if you got an answer like 18.5, you definitely couldn't have half of that. Maybe for a school bus, I could say, well, how much can I recycle the school buses for? 18 and a half children, I can't do a half child. But yeah, so a quantity is a value given some sort of perspective or reference point. Perfect. And there we go. And so I'm going to leave you with the challenge question. Can you think of a quantity that has no value? But that's going to be it for this one. And there you go.